Hi everyone, I'm Christine. I'm the CEO and founder of Asimovo, and my whole world is robotics. Okay, so it's very much with the perspective of robotics that we're talking about today. Okay. Yeah. Okay. So I also sit on the IEEE's. Hello? Yeah, that's better. Okay, so I'm Christine. I'm the and I also sit on the IEEE's Robotic and Automation Society's board for industry. And today it's all about robots. What do I mean when I say a robot? And then I'll go through a number of examples of how digital twins are used in robotics, from the most basic and to kind of where it's going to go and where it's already going. Okay. So first of all, what's a robot? Over 60% of robots that are out there today are these pick and place machines, robot arms behind a cage moving extremely fast in a factory. But we focus on what I call mobile service robotics, which is about 7% of the market. And they're almost all SMEs at the moment, which is really interesting. So it's an extremely fragmented and early stage part of robotics. And what do I mean by these service robotics? I mean ones that will be part of your everyday life. It'll change how we work, how we live, how we play. These will be robots that live among us, that will influence us on our day-to-day levels. So these are robots that are going to be used in uncontrolled environments. So we're not talking about follow the yellow lines down the middle of a factory floor. We're talking about flying over our streets and being in our schools and hospitals, okay? And so for those robots, it's also not just about the behavior of the robot itself, it's also about how that robot's going to interact with the people, how that robot's going to interact with other robots, and how that system works, okay? So we talk about very much kind of the future of work, or teams of the future. And what we talk about is that teams of the future will be a combination of automated services, robots, and people. And so it's about that combination. So it's not about necessarily replacing people in that system. It's about really much a system approach to thinking, a system approach to the job that's to be done, or the task, or the performance, and how can automating certain tasks, how can working together with robots really accelerate it and take us to the next level. So that's really what we're all about there. Now, robots have historically been a physical-led discipline. People building their box with wheels, people building their drones, people being very mechatronics. Oh, that's already cross-discipline, mechanics and electronics. But actually, when we come to service robotics, it's all about the brain of the robot. It's all about the behaviors and that complex task that robot is going to perform. So it's not just about the physical, the body, but it's also about the brain. Okay, so it's also about these complex behaviors, and how do you build these complex behaviors and train these robots, and how do they know how to behave in the public domain? So we kind of take a software kind of approach first, that you should be building your digital twin. And that should be a close representation of what's happening in the physical world. And these two worlds continuously interact. So you're building a very iterative software first approach, but bringing that hardware into the loop at any time. And the simulated data is where you start with, but later you bring that hardware in the loop data back into your simulation, your digital twin. So this is a kind of continuous new way of working. And we kind of talk about that for a digital twin in robotics. You've got the physical robot, which is very much about sensor and sensor data, and you're bringing that in. You're using a lot of simulation to build out complex behaviors. You've got AI and data models, which you can also bring in. So for example, you can train the robot about face recognition, and you can just bring that in as a certain piece of behavior. And you've got serious cloud compute needed, or even supercompute needed. Okay, and in the platform that we've developed, we allow you to also connect then people. So the people can be anywhere, the robots can be anywhere. We talk about the tools, so we have based this all on robotics development tools. So you're talking about robotics simulation and physics simulators for robotics, and robotics behavior building development tools, and also making sure that it's all very modular, so that as you build out your digital twin, You can take out your robot and another robot could go in, for example. You can have multiple robots on the same place. So what does this really look like? Let's see if this works. Yeah, okay, so this is an example of a simulation that we are using in robotics. So top right, you're seeing a simulator. This is the environment that's being simulated to the robots that's moving around. Top left is the view of the camera that's on the robot, and this is a simulated camera capturing the data from the camera. You've also got sensor data as that robot is moving around. So this is an autonomous agricultural vehicle that's moving around, collecting data as it goes. And at the beginning, you use this simulated data to help inform your digital twin. And then later, that can be replaced with data from the actual robots. And this has got an integrated development environment, so you can also have multiple people all logging into this same environment and multiple people adding different robots. The environment can be hi-fi, lo-fi. This is a little bit more of a high fidelity environment to have a drone moving around and a drone flying around here. Both of these examples, although it's autonomous behavior that we're looking at, it's from a single robot's point of view. So this is very much, I would call, the most basic use case. Single robot in an environment doing a single task. What happens if you've got multiple robots being controlled by different people? Again, this is a really simple example, but here we've got two different people controlling two different robots, two different missions, all in the same digital environment. How do they learn not to bang into each other? How do they learn not to move? This is just a fun example of a kind of drone system and how they work together. But this is very much controlled. What happens if one of those has a red card? It falls out the sky. Can that drone system self-organize? Can they kind of repair and be intelligent enough to fill in the gaps? Sometimes we're interacting not with people, but with animals. So something like Lele have had robots that move around and interact with cows for well over a decade. And now they use simulation, which is built from real sensor data. So you can use digital twins throughout the robotics journey. This, for example, is one of the universities that we work with, and this is a system approach to a field. There's a farmer in the tractor doing that job, but these are autonomous vehicles that work out when they're getting fuel, when one goes back to dock, and when the next one comes in. So these are all just examples of how robotics can be used. And something like this and that system approach is where kind of robotics is going to go. But if you actually take more of a digital twin approach to this robotics problem, and you kind of think a lot more about actually, let's do a system thinking first. If we talk about what is actually the problem that we're trying to solve and how are we going to automate it, should the robotics revolution be led by robotics companies? Maybe not. Where should the robots be the pawns in the game, and actually the people with the problem should actually be owning this use case? So for example, we're working with the Erasmus Hospital in the Netherlands, the biggest learning hospital there, about how they actually have got, and even just from a logistics point of view, 10 different companies all using a different level of automation from logistics, whether it's cleaning, it's food, whether it's moving beds, it's equipment. Every one of those is coming in with its own behaviors, its own rules. And should the robotics companies decide to do that, or should the hospital decide? So the hospital is now developing a digital twin. It's creating a digital twin of its own problem. And it's already beginning to say, okay, how do we want robots to actually interact with our staff? How do we want them to interact with our patients? How do we want them to interact with each other? How do we want to collect data and share data? Do we want all these robotics companies coming in and taking that data and owning it themselves? Or are we part of this? So this kind of standardization and how are robots going to influence how we live, work, and play is at the moment being led a lot by the robotics companies, but actually society will also demand actually a lot of input when it comes to actually how are we going to have robots living among us. So this is just an example project where you can actually simulate 1,000 different possibilities, 1,000 different things to improve efficiency, to improve interaction, but also for educating patients, making people more aware of what they're doing when they're coming into the hospitals, etc., and also the data. So a lot of the conversation today has been about data. Robots are going to be a huge, rich source of data for building digital twins of the future. So how is that also going to influence? So that's really what I wanted to talk about today. There's a big robotics conference coming to Rotterdam in September. These are going to be 2,000 of the world's best robotics minds. And there's going to be whole sessions related to industry and how robotics and industry problems can come together, and digital twins are going to be a big part of that. On our website, we've got a number of white papers around high-performing teams of the future and how robots will take part of that, or get in touch with me. Thank you.
Christine, our next question is for yourself, please. It says, who owns the data in your examples?
Most of the examples I showed here are all open source projects. They are outputs of research work that's been published, etc., etc. Sometimes the models are proprietary. So, for example, the inner models of the CAD wouldn't be shared, but the ability for something to move is open source. Most of the environments I showed are also open source environments. And then the people who then work with it are then developing certain behavior models, and they're also packaging them as an open source package. So we are also members of the Open Source Robotics Association. And a large part of what we want to do with robotics at the moment, because there's still a big opportunity to do it with the mobile robotics, is to make it as much open source and sharing for behavior building as possible. So when it comes to robot interaction, there is a robotic operating system that is open source, and most of the behaviors that we want to have for robot to robot or robot to human, we would like many people to contribute to building the rules of that, the rules of engagement per se, and that being less about one big company having all of that knowledge and building it internally. So almost all of the examples that we have, and on our platform, you can have a free membership, and you can go on, and everything is available for download as well. So if you want to take an environment that someone else has got, take it and build it, then you can do that, and you can share as open or as closed as you want. But if we want robots to really be part of our society, then society will demand some rules here. So I think having multiple people contribute to building those rules makes it much more acceptable and trustworthy as well.
Brilliant, which also goes on nicely to the next question here for yourself. Is the challenge of human and robot interaction also about trust?
Definitely, absolutely. And some of the examples that you see now, like the problem is when it comes to autonomous robots, there is no fixed rule book. It's still within academia. The early stages of autonomy are kind of written, but the human to robot part is not. You have some larger autonomous car companies that are just writing their own rules and publishing them, and they're saying there's 6 levels of autonomy, blah, 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 which is a little bit of an oversimplification. So there's going to be a lot of movement in this area, and there's a lot of very clever work going on, but it's not always necessarily being built on each other's work. So we're also trying to connect and share that as much as possible. A lot of, like, if you take human-centered approach to robots and you go talk to people who do dangerous jobs, sometimes they like doing the dangerous job. They don't want a robot to just come in and take it over. What they want is some assistance in the high-pressure wash or something. They don't want to replace the high-pressure wash. So how robots kind of will help an aging population do the same work, for example. It may be assisted tasks rather than the robot taking over the task, and teams of people will be will need to interact with robots on a day-to-day basis. So that trust will have to come both ways, and that comes from transparency, that comes from sharing of data, that comes from collaborative design processes. So, but there are a million use cases, and they will all be done in different ways. But yeah, sci-fi doesn't help with all of its take over the world stuff. But there's there's a lot of concern or worry when it comes to robots, and people's imagination can get ahead of them. And are humanoids the answer versus just something that helps you carry it a bit more easily?
So I've got a question to both of our speakers here, if I may. It says, so I think if you've got the mic, if we start first, should we approach trust and data sharing differently when approaching organizations and companies to use, sorry, let me read that again. Should we approach trust and data sharing differently when approaching organizations and companies when approaching individuals? Do we need different systems for both? So do we, I guess, as organizations and companies, need to consider how we might vary our approach for trust and data sharing depending on who we're asking?
I think historically in robots, it's been very much closed because it's being used in a factory that is owned by somebody, or the Lily cow cleaning one I showed, that's also very closed because it's within their situations. And I think that's completely different from when a robot's going to be used in a public space. So for us, I think it's much more about the use case, and it's about the specific task that's being performed.
Brilliant. And Christy, another question for yourself, if I could, is have you observed any unexpected human behaviours while they interact with robots? People seem inclined to, okay, I'm not going to try and pronounce that.
It's okay, because I can answer that. So we've gone to a trade fair and we show our platform. That's nice. Then we take a quadruped robot that basically is the dog robots, and you take it out and you turn it on and it just scuttles up and forward by somebody with a remote control. And I swear there's 30 people at your booth in like 0.2 seconds. People are attracted to the movement. They're used to things like that being things that they interact with. It's different from when you have a humanoid and it's looking at you face to face. There are multiple examples of robots going down the street and people kicking it, pushing it over, deliberately standing in front of it, deliberately trying to get it to fail, kick it over. And these are big, heavy machines. If they fall on you, they can hurt you. So some people are threatened, some people find it cute, there is no one reaction. So I'm going to a sports festival next month. We're taking a robot with us to purely understand and talk to the public about their feelings as they interact with this robot in a public place that they're not expecting is a technical place. So there's a lot more research needed here, and there is no one behaviour type. There's everything you can think of.
Very good. And our final question here, which I'm going to remove the political nature of it slightly, and just ask if you could look at one thing that could accelerate the future digital twin market, whoever was going to support it, so not only governments but others, what would that one thing be that you'd ask for?
And for me, probably the first time in history where there's enough data that can really, really be used extremely powerfully to have social benefit across a number of things. So what are the biggest issues of the day? Aging populations, climate, the future of work. These are all things that I think data and digital twins can really help accelerate. They can literally get everyone on the same page. They're cheaper for people to understand and understand the problem and get all around the solution before big infrastructural improvements can be made. So there's a big role to be played in society.